In this video, let us solve more problems based on trigonometric ratios. So here is a question. It reads like this. If tan theta equals 12 by 13, evaluate 2 sin theta cos theta over cos square theta minus sin square theta. Now before I begin to solve this problem, let me just brief you up about the different ways in which you can solve this and why we may choose one method over the other. So now, the problems that we've been doing till now, it's like if we've got one function's ratio, that is, say for example, if we had sine theta equals something with something, then we had two sides of a right angle triangle, and then we just had to find another one. So in this case, it's tan theta equals 12 by 13. So say tan theta is nothing but opposite by adjacent, right? So let's say this is theta. So tan theta is opposite by adjacent. So opposite is this side. So let's name this ABC. So the opposite is going to be AB, which is 12, and the adjacent is going to be BC, which is 13. Well, it's not accurate. It doesn't support that this AB is 12 and BC is 13 because BC is definitely smaller than AB, but this is just a representation. So let's not worry about that much. So now what's missing is AC. What's missing is AC. AC is the hypotenuse. So we can definitely find AC, evaluate for AC using the Pythagoras theorem. I mean, the hypotenuse square equal to the sum of the square of the other two sides. So in this case, we have AC square equals 12 square plus 13 square. So AC square equals 12 square is 144 and 13 square is 169. So AC square equals, adding this, we get 144 plus 169, which is 144 plus 169, 9 plus 4 is 13, 3, 1 remainder, 11, 1. So it's 313. Now is 313 a perfect square root? I mean, does it have a perfect square root? No, it doesn't. Definitely not. So now this is going to be a problem here. We have to use AC equals root of 313. This definitely is going to be a problem. So another method is to convert every function in this, sine theta, cos square and sine square, everything in terms of tan theta, because it's going to be so much more easier. If everything is converted into tan, we can straight away substitute everything by 12 by 13. So let's see how do we do that. Now see, this is one method, and what I'm going to do now is another method. And at the end of it all, I'll tell you why I chose this over this. Well, the reason I'm not going to do this is definitely because we don't have a perfect square root of 313. That's going to kind of make it complicated because we're going to have more calculations. It's not going to save much time for us. So that's the reason why I'm going to do the method which I'm going to do now. So what we have to do in this method is nothing but we have 2 sine theta cos theta over cos square theta minus sine square theta. So what we have to do is to make everything a tan theta. Now to make sine into a tan, we definitely have to divide it by cos, right? Because tan theta is nothing but sine by cos. So at the same time, we need to get rid of this cos theta because we are not going to make a tan out of this cos. So what we are going to do here is divide the numerator by cos square theta. Now since you've divided the numerator by cos square theta, you also have to divide the denominator by cos square theta. That's the rule of fractions, right? So let's see what happens now. So we have 2 sine theta cos theta divided by cos square theta, which is cos theta into cos theta. And this one we are going to have cos square theta by cos square theta minus sine square theta by cos square theta, right? Now this is like a common denominator for this one, so we can still split it. We can do it like this. So now let me continue these steps here. So 2 sine theta, let's keep the 2 like that. Sine theta by cos theta is tan theta, so we've got tan theta. Cos theta gets cancelled, so we've got 2 tan theta divided by cos square theta by cos square theta gets cancelled, so that's 1 minus sine square theta by cos square theta is nothing but tan square theta, right? So what we've done now is we've converted this entire function in terms of tan theta, which makes it so much more easier for us to just substitute the value of tan theta in here and then go ahead and find the value. So now 2 times tan theta is given as 12 by 13. So it's 2 times 12 by 13 over 1 minus tan square theta is going to be definitely 12 by 13 the whole square. Right? So the numerator is going to be 24 by 13. The denominator is going to be 1 minus 144 by 169. Yeah, so we've got 24 by 13 over 1 minus 144 by 169. So let's solve this part of it now. Just have to take LCM and all those things. So this is going to be 1 by 1. So definitely the LCM of 1 and 169 is going to be 169. So it's going to turn out like this. 24 divided by 13 over 169 minus 144 divided by 169, which is nothing but 24 by 13. 169 minus 144 is 25, so 25 by 169. So a fraction divided by a fraction is going to be numerator multiplied by the reciprocal of the denominator fraction. So 169 by 25. So 13 goes 13 times in 169, and we have 24 times 13 as 312. 312 divided by 25. So 312 divided by 25 is what you get when you evaluate this expression when the data tan theta equals 12 by 13 is given. So let us solve another problem. So the question we have here is, if tan theta plus 1 over tan theta equals 2, find the value of tan square theta plus 1 over tan square theta. So what can you do? It is actually pretty simple. There is not much of trigonometry here if you notice it carefully, because we've done these similar kind of problems in the topic called factorization before. So what we have to do is just take the given expression, that is tan theta plus 1 by tan theta equals 2. So if this is given, now how can we get this out of this? So we just have to square both sides. Square both sides, and that makes it what? Tan theta by 1, tan theta plus 1 over tan theta the whole square equals 2 square. So this is of the form a plus b the whole square, right? So it's going to be a square, that is tan square theta, plus b square, that is 1 by tan square theta, plus 2ab. 2ab is nothing but a is tan theta here, b is 1 by tan theta here. So 2 tan theta into 1 by tan theta, and the squaring of 2 gives us 4. So tan theta and tan theta gets cancelled. So what we have here is tan square theta plus 1 by tan square theta equals 4. The 2 here goes to the right hand side. So the plus 2 becomes negative 2, and therefore we have tan square theta plus 1 by tan square theta equals 4 minus 2, which is 2. So this is how we find the value of tan square theta plus 1 by tan square theta. So what I'd like to notify you, or what I'd like you to take note of in this video, especially in this problem, is although this topic that we're doing is trigonometry, you definitely could have noticed that there was nothing trigonometrical that we did about here. There's just nothing trigonometrical that we did here. It was all algebra. It was all basically factorization. That's all it was. It was, in fact, applications of factorization, if I'm not wrong. So if you want to get a deeper insight about this step that I did here, do visit the videos based on factorization and get back to this to understand this even better.